10 tons per hectare. Waste will be 50,000 tons. I assume that since I'm one-third land, Maharashtra has a
So just few more minutes. Huh? Please try to.
few minutes I have.
Just
Yeah.
2-3 minutes you try to.
Okay. So next. So here I have said that gas liquid product when I sell, next slide, I get some money, and then the capital cost of one pyrolyzer is 10 crores. The capital cost is 42 crores. Depreciation and interest is there. Operating cost is there. Total cost I know. Total income I know. And payout period is 3.1. Some money. Steel factory and then the capital cost of one pyrolyzer. If you give us a char, the blast furnace we will run on your char rather than the depreciation and interest. And our steel will be called green steel. Total cost I know. This is a benefit. Total income I know. But internationally, 3.1. There is now some money. Steel factory and carbon. They have requested one pyrolyzer. So anyway, we have a char. Carbon. The blast furnace we will run on your char. I'm emphasizing the depreciation. There is no business as attractive green steel. Total cost 3 years. This is a benefit. Income I know. But internationally, 3.1. There is now some money. Steel factory and 5 village they have implemented everywhere. Anyway, we have to charge. We get the 47 million run on our charge. I'm emphasizing depreciation. There is no business as attractive. We get 2,003 years. This is a benefit. Million metric tons. But internationally, 3.1. There is now some money. Steel factory and 5 village they have implemented everywhere. Anyway, we have to charge. We get the 47 million run on our charge. I'm emphasizing depreciation. There is no business as a product. We get 2,000. I go to use as a benefit. Million metric tons, but internationally 3.1. There is some steel factory and Tata real implemented everywhere. I try to understand. We get the first here it was run on our charge. I'm emphasizing so 20. There is no business as a product. We get 2,000. I go to use as a benefit. Million metric tons, but internationally 3.1. And there is some machinery factory and Tata Real implemented the past year it was and emphasizing there is no business as product creation. Advantage or I it is a benefit. What are your thoughts? Till about 5 million and there is some problem. Machinery factory and Tata Real implemented the past year it was this is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is about 5 million and there is some problem. Machinery factory and Tata Real past year it was this is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.5 million and there is some problem. Machinery factory and Tata Real past year it was this is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 and because of the machinery factory and Tata Real past year it was this is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 and because of the machinery factory and Tata Real past year it was this is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 and because of the machinery factory and Tata Real past year it was this is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 and because of the machinery factory and Tata Real past year it was this much energy. This is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 and we have been machinery factory and Tata Real past year it was this much energy. This is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 and we have been machinery factory and Tata Real past year it was this much energy. This is a process in our is no business as a product creation. 1 million or I is a benefit. What are your thoughts? There is 1.2 we have been machinery factory and Tata Real past year it was this much energy. This is a process in our is no business as a product creation. 1 million or I is a benefit. What are your societal problem? Then we make the society the scientific temper of the society. Able to solve this, the red mud or ilmenite sand. First of all, we do smelting and we will make titanium at the cost of aluminium. Big statement. Next slide. So now time is not there. Otherwise, I would have explained what exactly is the insight and why people need more than 300, 400 rupees. Next slide. In 1947, we received political freedom. However, we are more than 90% dependent in terms of technologies and new knowledge. We have 19 refineries in the country. If you want 20th refinery, we ask for technologies from outside. Are we independent nation? And like this in pharma, no new pharma product is made in India. There are small exceptions here and there, but nothing more. We need to begin with yet another freedom fight for our own abundant knowledge, innovations, and wealth. I have just 2 sentences to say. Our own filmmaker Satyajit Ray, he made one film And that film was Shatranj Ke Khiladi. You might have seen there was an invasion of Britishers to Lucknow, and there were two kings playing Shatranj. They did not even realize, these kings, that Britishers are coming and they are conquering, and they're complacent, so complacent, and they were entertaining themselves by Shatranj. So I made myself introspect every fourth Saturday of the month. Have we become complacent? Why the nation is poor? Why per capita income is in bottom 20%? Why there are 30% people below the poverty line? Thank you so much.
Thank you, Professor Bhim Singh. Sorry. Professor Joshi, we salute your innovative thinking, the way you have worked. Only one comment I'd like to make is, it seems you have found some solutions to the burning problems of India, including what we are getting pollution in Delhi or etc. because they burn the uh, Barari and all that. If you have those solutions, INAE would like to take them to the logical end, to the respect. So, but there should be solutions, not really R&D problems. But if we have a solutions, INAE will definitely try to take them to the logical. I mean, people like Gadkari, our minister, they are very open to INAE suggestions. So, if you have anything, I think our president, he will, Professor Patil, he will definitely like to take it, and INAE will try to do that kind of.
With you.
Thank you. Thank you very much. Our next award was supposed to be Professor Krishna Memorial Award to Professor Anil Kumar Bhowmick. He is not here. He will be joining last from USA. We go next, INAE Award, Professor S.N. Mitra Memorial Award, and I invite Professor Bhim Singh. Professor Bhim Singh, he's a ANRF National Science Chair and Emeritus Professor at Department of Electrical Engineering, University of Delhi, and internationally acclaimed electrical engineer. He's a lot of contributions in power electronics, electromobility, renewable energy systems. Uh, he has supervised 151 PhD students, which is the highest number anywhere in the world in area of engineering and technology. Under his mentorship, several startups have emerged, contributing to Make in India, employment generation, and technology self-reliance. With a large number of research papers, patents completed, sponsored research, consultancy projects, keynote addresses, he is a very well known person, and he stands out as a for his blending of cutting edge technology innovations, nation building, social impact, self-service to education. Professor Bhim.
Professor Dr. Goel, Professor Sanak Mishra, Professor Joshi, my other distinguished awardee today, present president, past president, and uh, distinguished fellows of academy, and my dear some of the young colleagues. It's a privilege. I am really happy to uh, for conferring the INAE to this award to me, and it's a great opportunity that I can speak something about typically about uh, some of the my thoughts in front of. Exactly, I didn't put completely that what really I have done past. So first I would like to certainly dedicate this award to my parents who never gone to school. I mean, they have been the typically farmer family. I mean, they have not seen the school how they have been, but I have really got inspired from them. I like to thank certainly to my professors who has been my master and uh, doctorate supervisor, Professor C.S. Jha, who has been one of the founder member for INAE. He used to talk to me when we sit together, and Professor S.S. Murthy, who is here, and Professor B.P. Singh. So I was the first guy I think can PhD student in IIT, they need to get 3 supervisors. Otherwise, normally it is 1 or 2. I mean, like typically. But in spite of getting a probably, I was very fond after my graduation from Roorkee to come to IIT Delhi as a master student. And one of the that time hobby was to get the job. So after even getting the 25 jobs, like a central government job, 3 times of engineering services and other jobs, state government, public sectors, my supervisor able to convince me why don't go higher studies. But of course they were knowing probably it will be difficult. So I joined as a project and then continue for the PhD and this journey. And I really very happy to come into the profession of engineering education, considering that probably even in being a government sector, I'm able to get around 15 years more compared to my other friends who have been in engineering profession. Like, of course, in academics, we have a 5 year more. Then I got this NRF National Science Year for 5 years, and next 5 years is also booked for through NRF Prime Minister Professorship, is already I have to start from probably next year, like for next 5 years. So government is really, I really thank to the government also that they are considering to take me to up to age of 75. Certainly I have to perform. I'd like to thank certainly to my student, especially the PhD and master student, really they work hard. Of course, I have to grill them like anything, including at the moment. I mean, Dr. Goel already mentioned in, of course, it's mentioned here 151, but 30 still are coming around. Next, since I have to go next 5 years, so I have to plan to about 60 more PhD students. Like that have been the probably the lesson that's about how it goes in the future. Apart from that, probably as a hobby, after the supernation year 2020, I thought it was a hobby as a mentoring the startup. So I will be probably there have been many technology which work out, but within whatever technology we took in the last several years of research we planned, within 5 years we should be the number one in the world. It does not matter whatever the technology we take. Of course, my engineering discipline have been very conventional in nature. Obviously, say hardcore electrical engineering, not related to computer and other things. But of course, there have been a lot of opportunity in that also, and probably gone from electrical machine to power electronics, then drive, then probably power system. Apart from that, renewable energy like a solar energy, and then the new upcoming technology, which have been a very old technology called electric vehicle. I mean, like which is coming up. Like so, in every I will be talking about today probably a little bit about the electric vehicle, which I mean I thought it, but after guiding around 15 PhD or student, around 10 PhD student are working in that direction. So I thought it okay, probably research. I don't know whether how it will serve the purpose, but I thought it is starting the some of the startup in the area which I am not really working, like a typically the lithium ion battery, then the BMS, then motors, then the chargers, and renewable integration into it. Like I mean also. So well, because time is limited, so I have to go also a little faster. And of course, I would like to thank my family, my wife. She dedicated, never disturbed to me, whatever, whether I want to work for 10 hours or 20 hours in a day or 50, I mean, around that. And I learned from my the children when I saw them at teenage age of class 11th and 12th working for 100 hours. I learned from that how to work for 100 hours in a week. I mean, and of course, they have been quite successful with the J15 and J12 and did AIMS only in, my daughter did medical in AIMS. So they have been very hardworking. I also really judge, I mean, they are able to do 100 hours per week at teenage age. Why I can't work at this age at the 100? Like, I still feel if I could have been my professor who used to say, Professor C.S. Jha, that the mind only work up to age of 40, I could have proved back similar to the 3 idiot Dean that yes, you are the wrong. My mind start working after the age of 60 or 65 towards doing to converting the technology towards the wealth if we can do something in that or so. So with that, of course, have a about on paper around 28 startups, but around 13 are successful, and probably every month one is added. Since I mean my well-wishers and my friends says everything is 100, whether it is PhD or whether it is a patent, why cannot be startup also can be hundreds? So that's the journey of next 5 years. I thought it to do it in spite of next inning of the life. Of course, family is not disturbing me. They are cooperating in all the respect to me. And of course, I already mentioned that government is also very cooperative. to give me a path for next 5 years. Otherwise, after age of 60, we start counting the day when we'll be going into the train of somewhere hell. So coming to back towards quickly for this, what really this electric vehicle, which really I chosen to work more prominently at the moment. Uh, if we look into the history, in 1996, the GM launched electric vehicle in Silicon Valley, and the company almost to become a bankrupt in couple of years because they have to withdraw all the vehicle. As it happens very recently with the Blue Smart, many of you might be knowing the taxi running in Delhi. They have, because of several reasons. I mean, reason I will not. But the technology which never develop, it never go to the waste. So it gets converted to hybrid. One of my relative purchased the hybrid car, which runs with the petrol and of course with the electric motor, and giving the average of 27 kilometers per liter. With the usual car give around 8 to 9 kilometers per hour. So it means the energy requirement even for hybrid, what we have in automobile car. Like. Well, if you look in the same Silicon Valley, the Elon Musk put the Tesla car, and I hope you know, in last probably 18 to 20 years, he's the richest person of the world. Very dangerous technology, but the required technology in the for the human being. The reason being 1/3 of the energy of the whole world, half the energy of the whole world goes to transport sector, and this is all your petroleum product. And if we are able to reduce, like I will talk about with some evidences, the energy requirement for electric vehicle is reduces to 1/6 to 1/10. If we reduce this requirement, and you can understand, if half the energy of ours goes to transport, and out of that, half energy we reduce to 1/6 requirement, I don't think we have to take the oil either from Russia or from America. So with the thought of that, I thought it why not to work in this technology, how much we can contribute towards that also. You might be aware, because it's all the time in the media, that you are able to, I mean, no new fuel, of course, very fast pickup around 60 miles means 90 kilometers in with Tesla mentions it, and then cheaper to run. I already mentioned the energy consumption goes 1/6 to 1/10. I was probably delivering, I mean, just to mention a little bit, I mean, 2020, in the year which I was supernating, I couldn't believe how it have been miracle because of COVID. We have it twice the COVID with my wife and myself because she done are already in North America, and they try to keep every kind of precautions, putting every kind of appliances related to COVID in the home. And why my wife asked to the phone, why you are wasting the money? They say we can't come during the COVID, even something happened to you. So we want to protect in that. But what I mean, typically, I mean, this this becomes the typically cheaper. Why it is during that period in 2020, I delivered around 56 talk online, and one talk I was delivering on electric vehicle. I was not knowing who is listening. They were the mechanical engineers. They say at the end when there was a question answer, they say you captured our car. Your car is totally belongs to mechanical engineering. So I have to mention no, we have not captured your car. We have only changed your engine of 30 to 35% efficiency to 95% of electric motor. And after that, we recover the 50% energy back through regeneration. That reduces the consumption of energy to 1/6. Very straightforward. Now, not doing any much innovation to it like all. But of course, that year given me a really leap of 2020, where I have to graduated around 15 PhD students with 120 publications, reasonably top in IEEE transaction around 80 publications, 240 conferences, and 15 PhD. And in spite of teaching the first year BTech course with 530 students, like I don't know from where the energy came. The reason being nobody was disturbing, because in academics, the what happens, everybody enters your room and it is undeterministic. And I consider, because of several reasons, I consider that profession not to so good, because you have to prepare the lecture in the night only on your personal cost. Okay, whether your wife want to sleep, your family want to sleep, but you have to prepare the lecture for the next day. I mean, but that probably time there was no disturbance for that. Sometimes it give a really bad shape, but it was really miracle year for me. And that has changed. I'm not able to maintain, trying to maintain that year till 2020 or so. Like anyhow, that's coming to as a little bit blip. So these are the some other benefits of health benefits. Like in Delhi, we talk about now odd even and so many things there. But probably electric vehicle may really pacify a little bit about that one. Like also, so energy security, other things. I mean, like one of the major reason have been the oil production. In 2010, it was balanced. How much was the production? Same was the use. But after 2010, the production of this petroleum start reducing and cost is, I mean, the requirement is gone increasing, typically majorly in the transport sector. We consider major consumption in transport sector only. So how it can be the gap? Either you look into alternative technology, or people start using less, and using less is not really the answer. So you have to look alternate technology, and that's the another reason forces the people to think about probably for electric vehicle, which I feel. The another technology which renewable in last 15 years I work out with the solar. We work out the solar. We are number one in the world in the solar as far as the deployment is concerned, working in the area of power electronics. Why? Typically, in year 2000, I took a delegation to UK, and I mean, we were we are supposed to plan certainly work on this energy. I told you are putting a lot of money, probably I don't know how many hundreds of crore government of India put to develop solar cell and efficiency with not more than 20-25% like all of that. I told some money you put for utilizing and as the engineering role of this like so we start working on typically the solar. But that's a different apart. At the moment, I'm not talking too much. Like might have guided around 25 PhD in solar grid interface or solar power generation, and we work especially to mention little bit. We work with the Shakti pump around. They gave 1 crore in Skaraviskar project, and they really gone to solar water pumping system, and probably the industry is number one in the country. And in the last 5 years, their stock have gone 49 times. That gives the evidence that really they developed something. Like, and they started another industry in EV as well as in another industry in solar vapor, solar model. They say we would like to develop everything related to that probably in our own country. That was the interesting. But you can just see how this energy, which is required because electric vehicle you can run with electrical energy you can produce by other means. And this is the one of the way that you can get electricity generation from solar or wind. And solar you can see from 6.47 rupees, 6.5 rupee to it has gone 2 rupee in year 2020 or 21. When the panel cost was around 32 rupee per watt or 32,000 per kilowatt. Now the cost of panel is already gone less than half. If you go to the straight, really very standard panel, it's already 16 rupee per watt. And if really you go to raw, typically a gray market, which really flourished around 50% in India, coming from neighboring country, it's around 10 rupee per watt. So if it is a 10 rupee per watt compared to 32 rupee per watt when it was the cost, I expect in next 5 years, certainly it's supposed to be go to 1 rupee per unit. In Middle East, it's already 1 rupee per unit. All the why Middle East put really lot of effort for because they need a lot of energy for air conditioning or otherwise. We talk about the all the country which really have a lot of oil even, and they are very sure somebody will take the oil by either you kill the Saddam or you do whatever war, nobody will leave the oil with you. But if you deploy the solar on your rooftop or anywhere for use, nobody will take probably that. So they start investing, and probably even Indian companies start also in oil company of India start also investing. Most many startup as well as in the solar generation like. So we expect in next 5 years this will become further half 1 rupee. At the moment, in central government in Delhi, purchase around 125 electric car and put to secretaries and additional secretary rank. And what it was put in the paper that those cars are running with the 80 paisa per kilometer as a fuel charges. If that is the 80 paisa with this, typically the energy produced like a 2 rupee by solar, if we reduce to 1 rupee per unit, we expect the car will run next 5 years maybe only 40 to 50 paisa per kilometer. That will go as usual if we are able to produce the energy at such low cost like.
Well, sir, next 5 minutes, please.
Only 5 minutes left. Okay. Yeah, that will be more than enough too. Okay. So I can go a little faster. These are the technology, of course, concept and the classification. And you can think about only 215 watt two-wheelers. I mean, or I can say this will, that's a 250 watt two-wheeler can drive with the one unit of electricity, you know, how much? 65 kilometers. And who drive this? Your 50% population, girls and ladies. And of course, the speed limit is there 25 kilometers per hour. But it suits you well, very well, Neither dupatta will fly nor the sari will fly. They have restrictions now. And they can drive the short distance to their office and all that. So it suits you very well for 50% population. Such a economic, like in 5 rupee, you can drive a whole week of around 65 kilometers if you have short distance of travel like also. But you can think about this is another way. You know how much 82 kilowatt motors into it. Who drive it? Your teenagers, boys. And in the back, why such high power? Because if in the back, if somebody else is sitting, they will like to make it aeroplane. That's the requirement also of a reasonable population in the world to drive it. I think many industries coming up with this. Even a four-wheeler use only 81 kilowatt, but a two-wheeler use 82 kilowatt. This is the technology you can think about. I'm just trying to probably mention it, how it really differ from one. And this is the technology for India. You know why this at the moment? I mean, the e-rickshaw, illiterate people employment, 5 crore, and every year 50 lakhs are added. If you add something into it, will it pay back a lot? I mean, the more important, I feel important here to create the employment people of uneducated masses. Like this is one of the technology which really can provide employment generation, especially employment generation to uneducated masses also. So there are many activities which can be around this. I just put the photographs too typically. And Indians are so crazy. They start able to put solar panel to this. They clearly say 50% you can increase the range. From 90 kilometer, you can run 130 kilometers in a single charge. It supplement that. Like I asked my student that it is so interesting to look into maximum power tracking of this solar because now this e-rickshaw is going below the bridge or below the tree and suddenly it comes into sunlight or so. So putting the concept like and just see typically the kind of activities Nescafe Sophie. So on the too much children e-rickshaw, typically ice cream vendor can use it. So these are the activities, I mean the public themselves, illiterate people are bringing this technology into the use for the people to human beings like I mean typically also. So that's a now vegetable soap. So lot of variety. I put a lot of photograph in the sense in then these are the kind of activities you go with this kind of three-wheeler of electric vehicle and also. This is another one you can think about how fast the Tesla put. He claimed it does not matter the cost. I mean, he's able to sell probably a car of 1 crore rupee. A lot of people are there in the world. Even India, if you float this, people will buy it. He will not be able to meet the requirement of so much, but the quality that you don't touch for 15 years this car. Even if you buy the petrol car, na, you have to send 4 times in a year for the service. But this car, he claimed, I mean, the Tesla claimed you 15 years you not to go to service or anywhere else. Like in its spite, it has a battery and everything. Like so, it's a question is that how reliable. I mean, what quality of technology you put it. How the typically, I mean, we talk about that, okay, your combustion reduces to 1/10. If size reduces, volume reduces, cost reduces, loss, all suits well, and we use the single stage gear 1 to 10 or 1 to 20 like, also. So that's exactly too little mentioned to about it, okay. And I mean, of course, people use initially induction motor. Tesla use induction motor because it was proven for 125 years, okay. But let the other fool prepare well another motor like permanent motors now 15 years that's developed and Tesla also picked up quickly with if it is a better motor also. So coming out this, then another is the charging infrastructure. I mean, this is a kind of classification, but you can think about a modest car have to use the 4 charger, fast charger, single phase charger, three-phase charger, and wireless charger. I mean, you are taking a so costly car. You will not have a patient to hook up the connectors. Na? You go to the home and put the car on the platform and it starts charging. The technology, this is coming up as a wireless charging, to mention it. Just to mention it, Tesla have a wireless power transfer in 8085 or 80 around 1900. After 125 years, MIT repeated the experiment of this wireless power. Repeated the experiment. MIT is supposed to be a big for research, no? But they repeated the experiment of Tesla and After 4 years, Nissan brought the product called wireless charging. Now 20 industry are manufacturing this wireless chargers, like because there is a demand. And every car, if you think about, if you have a in India 100 crore car, 400 crore charger will be required for or so. So that's to come up. That's the fast. I like this slide that you can have a charging station, fast charging station. Why you can put wind, you can put solar, you can put the fuel cell, you can of course put the battery also for the power leveling to take from the grid so that grid don't feel any exertion or so. Like people are crazy. Think about solar and wind together, and they claim that 2 lakhs to
We can conclude
34
now,
unit
quickly,
it will
please.
give in 1 year. 1 minute I will take and just coming up like, and then so much miles it will run also. Well, we have a technology called vehicle to grid to vehicle, and all the purpose it can serve around also. And of course, there is a government of India put a mission, of course, to improve further on the motor part. And you have a lot of missions like rare earth material mission, semiconductor mission, which really support to have support to this also. What we expected that we have a technical manpower development for post gadget, under gadget, and then publication, patent, protect, and more important is the startup for the creating the job. And thank you. Sorry, I've taken probably few minutes more.
Thank you very
If
much,
any
Professor
question there,
Singh.
I will
So
be
nice
happy
of
to
you.
answer. Thank you.
Our next awards are Outstanding Teachers Award. We have two awardees. First, I will request Professor Sirshendu Day to give us a talk. Professor Day is from Department of Chemical Engineering, IIT Kharagpur. Is a well-known teacher for his courses in advanced mathematical treatment in chemical engineering, novel separation processes, and transport phenomena. His NPTEL lectures on these subjects are extremely popular in the country and also abroad. He has developed an advanced membrane separation laboratory and designed and fabricated a number of relevant equipment for research and for undergraduate laboratory students, etc. He has worked cross-flow cells, batch fabrication cells, hollow fiber spinning units, electrical field enhanced filtration setups, etc. He's worked on arsenic and fluoride mitigation in rural areas, particularly in Assam region, led to awareness generation of capacity building among the stakeholders. Professor Day has written 9 books with his PhD students, and they are well accepted in academic circles. Professor Day.
Dr. Goel, Session Chair, Professor Joshi, other co-awardees, and
Professor, 20 minutes, please.
Yeah, I'll finish, in fact, earlier. Present and past, presidents of INAE. At the outset, I would like to express my gratitude to confer me this prestigious award that will definitely encourage and motivate me for doing, uh, in my further teaching and research. So in this particular talk, I'm just covering a journey, how to, my experience from a metamorphosis from the researcher to the researcher entrepreneur. So my research is always being motivated by the following factors: to do translational research and to develop a process, a product that would be useful to the society at low cost, efficient, having tremendous outreach capability without compromising the quality. The development of sustainable ecosystem so that the utility of the products are exploited commercially. So with this motivation, we started to develop some products. Of course, the timeline will be is anything around 10 to 15 years from the start of the research to the final product. So I'll be talking about some of the products that have been generated in my laboratory and commercialized. First one, the treated laterite for the arsenic removal soil, lateritic soil that is available naturally. So the closest competent to this particular material for the arsenic and the arsenic removal is the activated alumina, which is a synthetic material and therefore expensive. Developed this material and did some chemical treatment and enhanced it arsenic removal capability several folds, and it's in granular site so that we can develop an absorption, packed bed adsorbent as a filter. So the typical capacity, of this particular material is 46.5 milligram per gram for the total arsenic removal, and it is one of the highest among the granular materials that we have that is reported till now. So another striking feature of this material, it has a long life. The filter can be sustaining its performance till 5 years within a range of arsenic fit concentration anything around 100 to 500 microgram per liter without regenerating during its lifetime, thereby reducing its operating cost extensively. And it does not interfere with the competing ions present, and it can work in a wide pH range. And this particular material has been developed in the laboratory first. Then we scaled it up, and ultimately we came up with a reactor of capacity 500 kg per batch and installed it in one of the production facilities. This particular technology has been approved by the Arsenic Task Force, Government of West Bengal, as well as the Mashalkar Committee in Ministry of Central Ministry. So after that, this technology has been transferred for commercialization to 3 companies. The timeline goes like this. We started research in 2002. We got the DST funding in 2008 by showing the preliminary results. And then we deployed domestic filter and looked after its performance. And in 2011, we got a huge funding from UNICEF, and we deployed one community scale filter in one of the affected schools in one of the places in close to Calcutta, where the groundwater is contaminated with the arsenic. So then in 2016, 2015, we got the recommendation of Arsenic Task Force, Government of West Bengal, as a viable technology. And in 2016, the first technology transfer was taking place, followed by another 2 companies. So it is really took around, 15 years effort to convert a technology that has been developed in the laboratory to bring it to the field. Currently, there are about 550 community scale filters deployed in various affected areas in West Bengal, Bihar, Jharkhand, and Assam, catering to almost 7 lakh people. The community scale filters are having capacity 2 meter cube power, 5 meter cube power per hour capacity. And typically, these are solar driven, running for 10 hours a day, generating around 10 to 50 meter cube of arsenic free water, catering to a cluster of villages. The next one I will be talking about the fluoride removal from the groundwater. Like the arsenic causes a skin cancer that is known as the arsenicosis. Fluoride causes a disease known as fluorosis. There are 2 types of fluorosis. One is the dental fluorosis, another is the skeletal fluorosis. It basically, in case of dental fluorosis, it weakens it spoils the enamel of the teeth and deform the teeth. And in case of skeletal fluorosis, it weakens the bones, and it causes the early onset of osteoporosis. So, therefore but the typical concentration in case of arsenic, it was 10 microgram per liter, but in case of fluoride, it is 1.5 milligram per liter. So there is a huge difference of order of magnitude, because fluoride is required to our body, required for our bones to some extent. Now, like arsenic, we try to look into what is the source of contamination of the fluoride in the groundwater. We have found out that fluoride is always adsorbed to the rock in the form of the mineral phase is known as the hydroxyapatite. Then we tried to mimic the nature like arsenic, like the lateritic soil that we have used for the arsenic. We tried to develop the hydroxyapatite phase in the laboratory, and then we have found that the phase that has been developed, it is in the powder form, which is having a very high capacity for the fluoride absorption. But this powder cannot be used as a typical media for the development of a filter, because that will require tremendous pressure drop and the leaching of the material. Okay, so therefore, what we did, we used activated charcoal, commercially available activated charcoal, and then we tried to generate this hydroxyapatite phase in situ on the surface of the activated charcoal particles, granules, and inside the pores. And we were successful, and ultimately we got a absorption capacity of the fluoride 105 milligram per gram, which is at least 7 to 8 times compared to activated alumina granules. So again, this particular technology was recommended by the Fluoride Task Force Government of West Bengal, and we have commercialized this technology to an entrepreneur, and currently around 35 such filters, community scale filters, have been deployed in the affected districts of West Bengal, Bankura, Purulia, and Birbhum districts, catering to around 50,000 people. Next, I'll be talking about some of the membrane separation process. Actually, my research in water treatment has started with the membrane-based processes. And we have found out that whenever we are talking about some experimental setup, it is very expensive. And most of the setups that are available, they are basically, we used to import from outside, like Sartorius, a German company, Vargov, it's another German company, GE Waters, US-based company. So these experimental setups were pretty expensive. So what we did, we tried to, develop our own setups, and found out our own design and our own fabricators, and came up with number of such setups. All of these are the laboratory scale setups, which are we are using as a product. And uh, like, I can give one example of this electric field enhanced ultrafiltration. In this particular setup, we can use the filtration of the charged macromolecules, and at the same time one can measure the one can measure the zeta potential or surface potential of the membrane by applying an external electric field. So the cost of this particular setup is around 5 lakhs, and we can measure the zeta potential, and the commercially available instrument that is available for the measurement of the zeta potential is ZetaCat, that costs around 45 lakhs. So each of these instruments of the same identical specifications have been supplied by GE Waters to different laboratories, but each of these instrument was costing around in the range of 15 to 20 lakhs, whereas each of our instrument is in the, we sell at between 4 to 5 lakhs with 3 times profit. The next one that is very important is the hollow fiber spinning unit. Like the flat sheet membranes, another configuration of the membrane is the hollow fiber. Hollow fibers are becoming very important nowadays because one can pack large number of hollow fibers in a bigger tube, so that the filtration area will be maximum in a smaller volume. So therefore, the design of the cartridge becomes very, very compact. So in case of hollow fibers, the principle of producing spinning of hollow fibers is very simple. It is basically an extrusion process with two coaxial needles placed, and in the in the annular space we send polymer solution by using the external pressure, and in the middle point we send the water being anti-solvent to the polymer. Whenever the polymer comes in contact with the water, the polymer gets solidified, forming the hollow core running along the length, and then the polymer thread is falling on a gelation bath that is also made of water. So the outer surface of the polymer gets solidified, forming a solid hollow fiber. And the typical internal diameter of such hollow fibers for water treatment are 500 to 600 micron, and the outer diameter is around 1200 micron. So these are thin fibers. So a typical hollow fiber spinning unit costs around 2.5 crores that we import from outside. One particular company in Bombay, it sells a hollow fiber spinning unit currently at the cost of 105 lakhs. So we developed our own, and the heart of the hollow fiber spinning unit is called a spinneret. That is basically the extruder. And every company nowadays, they are purchasing a Japanese spinneret, which costs around 75,000 US dollar. We have developed our own spinneret. So these are typical spinneret, the tailor-made spinneret that we have with the stainless steel body and Teflon bush, and it can be used number of times. And then we have developed our own spinning unit, which is very user friendly with all the specifications I have, and we can produce hollow fiber of different kinds. Like one can have microfiltration grade hollow fiber, one can get the ultrafiltration grade hollow fiber, nanofiltration grade hollow fiber, one can have mixed matrix hollow fibers, typically embedding various inorganic and organic particles like powder activated carbon, titanium dioxide. There are various other inorganics. We can embed silicon dioxide, so that these hollow fibers will be having some special characterizations for typical adsorption towards the smaller size solutes. So I'm having a video here of just 1 minute, how to spin the hollow fibers. So here, this is the spinneret that I was talking about. Then the hollow fiber is being spun, and it is going through the gelation bath, and then it is being wound in a spool, and the spool is moving translation wise so that the fibers are not being wound on the same spot. They will moving in the lateral direction like a like the bobbin in a sewing machine. So uh, this particular unit we are selling at the cost of 15 lakhs, which will be at least 7 times less compared to any Indian product that has been available in the market. Each and every part of this machine is Indian, is entirely an indigenous product. So with this, bouquet of products, we set up a private limited company in 2012, incubated IIT Kharagpur, Technical Separation Private Limited. And till now we have, and there are only four employees are there who are managing everything in the production unit of 1,000 square feet. And currently we have deployed domestic filters up to 2,000 liter per day capacity, more around 50, and lab scale membrane separation setups. We have sold around 35 such units, and one was sold to outside to Cameroon. Our clients are, Police Training Institute in Salwa, that is one of the military station near IIT Kharagpur. We have deployed our filters. The Women College in Mindapur, Ramakrishna Mission in Belghoria. There are 150 plus individuals in North 24 Parganas, Kolkata, Kharagpur, around Kharagpur and Mindapur area. The membrane units have been sold to various academic institutes and research institutes, including several IITs and NITs. So final takeaways from this exercise is that the nature is our greatest teacher, and we should try to mimic nature. If we really do something, then that will be the best way of solving a particular problem. We also think about simple operations with simple conditions like room temperature, ambient conditions like ambient pressure, so that the energy expense will be less. We should not use the non-scalable equipment like high-speed centrifuge, freeze dryer, etc., which cannot produce, in mass scale product. We should not use the analytical grade chemicals. We should use the commercial grade chemicals, because analytical grade chemicals are always 5 to 6 times more expensive compared to the commercial grade chemicals. If we want to set up a production unit with the analytical grade chemicals, we can never be able to make a business out of it. We should check repeatability of the properties and the performance of the products with the solid scientific and statistical test. And of course, there needs a continued sustained effort. It is not that a particular PhD student has done on a particular topic and then he leaves and the project ends there. Next set of people should take it up and move it forward. And we should take, for any product or any process, we should take the approval from the regulatory bodies. Without their approval, no entrepreneur will come up for commercialization of the technology. We should not be frustrated dealing with the government officials, local authorities, common people, and infinite patience and positive attitude should be prevailed to bring a technology from the laboratory to the field scale. Thank you. Thank you, sir.
Thank you very much, Professor Day. And personally, I appreciate very greatly the social relevance aspect of your technologies. And I wish that some of these, very interestingly, I was hearing a talk from one of the person from the Planning Commission long back, that many animals, including man, from some areas where the arsenic problem is there, they actually have less height, even the animals, compared to the rest of the Indian average, mainly because of these things. And if you remove those people, when they went to other area, again they got a normal height. So these are some of the very important things. So congratulations for that. Thank you very much. We'll now move to next talk under the same category by Professor Kulkarni. Professor Kulkarni, 20 minutes, please. Professor Kulkarni is a professor in the Department of Electrical Engineering at IIT Bombay. He served as a INAE chair professor in the department, and currently IEEE PS Distinguished Lecturer. He was editor of IEEE Transactions in Power Delivery. He worked at Compton Grips Limited from 1990 to 2001 and specialized in the design and development of transformers up to 400 kV class. He received an INAE Young Engineer Award in 2000 and AICT Career Award for Young Teachers in 2001. He authored a book, Transforming Engineering Design Technology and Diagnostic, second edition, and received the IIT Bombay Research Dissemination Award in 1916 for the book. He also developed a virtual laboratory to effectively teach involved concepts in electrodynamics. He has done more than 225 publications in reputed journals, conferences, organized several training programs on transformers and computational electromagnetics, and completed many industry consultation projects. Professor Kulkarni.
Distinguished attendees of this convention. First of all, at the outset, I would like to thank INE for considering me worth for this award. I'm really truly humbled. Since this award is on outstanding teacher, my talk will be on my contribution related to teaching and education only. So So just a brief, my career, most the highlight was initially I worked in industry for 11 years, and while working in industry, I did PhD in external mode, and then after finishing PhD, I joined IIT Bombay, and in 2000, I got INE Young Engineer Award, and probably I was the first one from industry at that time to get INE Young Engineer Award since it was established in 1996, because that time I was working in industry. And then while working in industry, I was also key trainer to staff and workers in local language. So the teaching was inbuilt. I was sort of habituated to teaching, and naturally I then shifted to academics. So again, I will restrict my contributions only to the education and teaching. So the as was the 2 hours, the first 2 hours I already been mentioned in my introduction. I was also given citation award by CPRI in 2014, and the the fellow grade of IEEE was for my contribution to transformer engineering education. And of course, I got fellow grade of INE in 2012, mostly for my contribution in transformer education. So I published a book. This is the second edition in 2012. This has now 1500 citations, and this is referred worldwide, and it is a reference book for transformer industries globally. So initial part of my research at IIT Bombay when I joined was in coupled field transformers. That time it was a new, relatively a new field, wherein I developed codes for multi-physics simulations for various problems in transformers, and wherein as you can see in the slide, there is a coupling of various fields, and these kind of problems are there in every product, and this give me a lot of publications. Later on in last 10 years, primarily I worked, moved to little bit of physics also, and worked on magnetic hysteresis and modeling of magnetic hysteresis in magnetic materials, and a lot of complexities related to hysteresis phenomena in magnetic materials related to dynamic effects, harmonics, and anisotropy have been handled by my PhD students. Uh, I would restrict again my research papers which have high educational value. So some of the examples that I wanted to give was, since I initially for 11 years worked in industry, I knew the problems faced by industry people, particularly in understanding some of the
phenomena that are observed during the design, during the testing, and at site. So after I joined IIT Bombay, I first, tried to solve many of those problems, and such problems I'm just listing now. One is the half-ton effect, which was, known by industry that such effect is there, but I tried to, give a complete holistic explanation of the whole thing, and that was appreciated. Uh, Next is on eddy currents. My PhD, in fact, was on worked on eddy currents and tried to publish papers in the areas wherein a lot of insight into eddy current phenomena are obtained by the researchers. Then I also worked on mechanical design aspects and improving the reliability of large transformers. In that respect, I analyzed the short circuit forces by using finite element method, as in this slide. One of the next contribution was in transient analysis, very high frequency transient voltage related to gas insulated substations. When there is switching in GIS substations, it affects equipment like transformers, and very high frequency transients are imposed on the transformer terminals. So you need a very advanced technique in terms of modeling this transient. And one such technique is multi-conductor transition line, wherein each turn of a transformer or any electrical device can be modeled as a transition line to capture high frequency transient phenomena effectively. And one example I would like to give in the area of testing, when transformers are tested, all three-phase transformers, typically, there is a asymmetry in the losses measured between the phases, and the asymmetry can be very high. And for small distribution transformers, one of the phases can read even negative. And for quite some time in industry, this was really a puzzle. Although the total loss would come less than guaranteed value, but there was high skew. Again, that phenomenon I explained through clear formulation, and this paper is a copy of this paper is there in most of the test labs across India and abroad, and whenever such thing is observed, they just refer to my paper. So now, having told my contributions as in the area of education, I would like to give some comments on today's educational field and the challenges thereof. So I would like to, but just give a anecdote of my journey of this thing. It started in third year of my engineering, and in it so happened that the topic taught by the instructor was very difficult, and students were making noise, and I was picked up by the instructor and told that I was told tomorrow you have to give the class. This was in third year engineering. It was a very difficult topic. But then I took that as a challenge, and next day morning I prepared and gave that lecture. And the students were not knowing, and they were surprised that, how come I am giving a lecture. So that was the beginning of me as a teacher. Uh, as I summary of my contributions, one is called the book. Then I have done one NPTEL MOOC course, several invited talks, and I have arranged symposiums, particularly on in the education in the area of education topics. I have also mentored many interns, and particularly I am very happy to share here that I have mentored many INAE interns in summer, as many as 7 teachers and 9 students in last about 7-8 years, and that has been very fruitful for my research areas. And yeah, these are some numbers. Many lectures I have been giving across engineering colleges and all that. I have developed 2 laboratories. One is in the area of high voltage, and one a virtual electromagnetics laboratory, wherein electromagnetics is considered as a very difficult to teach and understand subject. So I have tried to basically, through this laboratory, teach many difficult electromagnetics concepts through interactive mode and, using applets. So next the last 2, 3 slides only. So just wanted to give some comments on today's educational landscape and, role of we as, teachers. So I see that, what are the trends. The education field also is going to get little bit disrupted in coming years to various things. One is, of course, establishment of foreign university campuses. Students are inclined heavily towards IT, and there is a heavy skew, undesirable skew now between core and non-core engineering branches, which is not healthy. Student employability is issue. Retention of our own UG students for further studies is not so great. Exponential area increase in AI and its impact on jobs. And yeah, and the opportunities, of course, are there. NEP to 2020 offers us a lot of solutions. I have seen in recent times, particularly in Western universities, they have started something like general engineering disciplines. So whether we should also do something like that, I would just put that thought in your mind, because what is happening is today's, in the first year when students join, they have certain ambition to do graduation in a particular area, but they are forced to take in some other discipline. So this general engineering approach would give a lot of flexibility in addition to major, minor, degrees that are already established. Yeah. So yeah, we need to basically, I feel, reorient departments into various areas with specific research focus rather than having especially electric students taking IT, and that is we need to mentor them and sort of excite them to take up some of the core engineering. Language barriers and weak communication skills, even in the IITs, there are problems, and we need to take care of that. Today's students, they are not able to of various digital and they get stressed. And basically, I have observed that we are, in order to de-stress, sometimes we actually using the academic rigor, which is not desirable. There are uncertainty in placements. I think these mentoring aspects, I have already shared some of this. Since the time is little less, I will um, skip these points. For the last point, I will like to stress upon that I have found, observed in my career that IIT faculties are heavily, approached by, industries and for consultancy and all that. I feel that we need to really develop second tier and third tier institutes and their faculty so that the load of IIT faculty gets reduced and we get a good ecosystem. So, and to that extent, we need to really, the first and second tier IIT and other renowned colleges and their teachers, they need to really handhold some of the engineering colleges for, further improvement. So the last, aspect is faculty members. So I'm talking of early career faculty members. What are their, say when they join, uh, see, in our times, it was only like teaching and research. These were only two aspects that we needed to basically take care. But now faculty members who join an institute, they have to they are expected to do many roles, and then basically, how do we balance between these various roles is a question. In addition to this, balancing between roles, the publication pressure is too high. Added to that, there is a publish and perish syndrome, everybody knows, and added to that, this, proliferation of, online of open access journals is there. And I have observed that many of our faculty members, IITs and other institutes, they are spending thousands of dollars per paper to basically get their papers published in open access journals. And this has to be, handled at, highest level through policy level. Because the kind of foreign exchange we are losing is quite high. And in that same connection, I would like to, suggest that we all faculty fraternity need to encourage our own Indian journals like Sadhana from ISC and INAE transactions. Just and to that extent, then we will try to solve this problem of open access. I think this is the last slide. I wanted to talk on effect of AI and ML on education and we faculty members. So yes, there are many issues we keep discussing about AI, particularly students taking advantage of AI for various reasons, and there are unethical practices. But this is now like mobiles and digital technology. This is like obvious, and we can't actually go away. We have to adapt and adopt AI, and we have to just see how we can use AI for betterment of our training and education. Only one example I will give. This last took a course wherein I taught technical communication to the MTech and PhD students, and then I needed to give them 250 topics, different topics, to for them to give seminar. So creating two topics was almost impossible. When I asked ChatGPT to give that under 5 different specializations in electrical engineering, it within no time it generated 250 topics, and all were almost distinct. So this is one example that I am giving, that there are certain advantages of AI, and we need to exploit, and we have to always whatever work we do, we have to see whether we can use AI well to increase our productivity. I think this concluding remarks. I would like to acknowledge my mentors, teachers, and students for all what I have been doing. Thank you.
Thank you, Professor Kulkarni, for very interesting talk. Only one comment I'd like to make is that, like technology, education is also evolving. And as a part of that, the student of today is much more smarter than what we were at
Yes.
that time.
Yes.
Thank you very much.
Thank
We'll go to the next category of award, the INAE Women Engineering Award of the Year. I invite Dr. Geetha Manjunath. She is the founder of and CEO and CTO of NIRA MAI Health Analytics Private Limited, a startup which has pioneered in new non-invasive imaging tests for detecting early breast cancer. With extensive experience as a researcher at CDAC, Hewlett Packard Labs, and Xerox Research, she envisages the benefit of using machine learning based analysis over high resolution thermal scans tissue activity. She led her team to develop thermodynamics cancer screening test, which is now clinically proven to detect as small as 4 millimeter and regulatory approved in 20 plus countries. With this innovation, first time ever women can detect their cancer in privacy with no touch and no radiation. This affordable, accessible, and high quality cancer screening test is creating a breakthrough in cancer care for developing countries. She won many international and national awards, including Women Entrepreneur for the year 2020 by Biospectrum India, and also she's on the Forbes top 30 Indian minds leading in AI resolution in 2024. Dr. Tanjanath.
Thank you very much, and good evening, gentlemen, and few ladies in the crowd. So it's a real honor and privilege to be among the top lifetime of achievement thanks once again for giving recognition of being Women Engineer of the Year award. Of course, of technologies in Hewlett Packard Labs. I was a principal for years. Then I was head of AI research lab uh, many years. Initially started off my career at CDAC Bangalore as one of the very young engineers being part of the first supercomputer being developed by India, which is Param and Paras. So yeah, over all of these years, and I've worked on 25 to 30 plus very, very interesting projects. But what I thought today is just spend one deep dive into one project, which is, just I'm spending day and night on it for the last few years, which Sir has benevolently given an introduction as well. We talked about, in the previous speaker talked about how AI is being used in education. And what I'm going to talk about is how AI can be used and is being used in the field of healthcare. This is a research that I started and quit my job and started as a startup 8 years ago, and it's been a wonderful journey. Just want to take you for the next 10 to 15 minutes into the deep dive of this so that all of you can take away something for you, for your family, wife, sister, aunt, mother, daughter, everybody. Okay, so we all know that artificial intelligence is being considered as a revolution in many fields, including in healthcare. And the first field that is primarily impacted with AI in healthcare is radiology, because radiology involves recognition of patterns in images, videos, etc. The X-rays, the medical images, we are talking about X-rays, CT, MRI. It's very, very hard to actually determine very, very small, minute variations, which may mean cancer, which may signify future cancer or current. Now, here, of course, there's several things that we talk about, how it can help, improve productivity, reduce misdiagnosis, calling out somebody as cancer when they don't have, as well as missing cancer, right? Both are considered as misdiagnosis, etc. But what I believe very, very deeply where AI should be used after my PhD in AI from ISC and 20 plus years of working in the area of AI when it was not even as much hyped as it is today, I feel AI should really be used to bridge the gap between the healthcare divide that exists between the rural areas, urban areas, the haves and the have-nots, right inside a city like Bangalore, or even the developing and the developed countries. It can be a huge boon to actually give this AI-based robotic doctor, if you will, to a rural healthcare worker to ensure that the right people, the high risk people, are identified at the right time and brought to the hospital, which is, of course, far, far away with a lot more infrastructure than what is there in the villages. So that's one main reason why I started Niramai to solve this one of the biggest problem in women's health, which is basically affecting 50% of the population in the world. 2,000 lives die every day because of this disease. Unfortunately, while breast cancer is completely curable, nobody needs to die of breast cancer. Every alternate lady detected with breast cancer is dying today within 2 to 5 years. This is completely solvable problem, I feel. Nobody needs to die of breast cancer. The only magic thing we need to do is how can we enable all of them to detect it in stage 0, stage 1, as opposed to waiting for a huge lump before they come to a doctor. What that means is by the time they feel the lump, it's already 2 centimeters or 2.5 centimeters. It is stage 3 or stage 4. Because of this reason, late stage detection having high mortality, we lose almost 50% of ladies today in many, many countries, definitely including India. In India, every 3 minutes, one person is detected with breast cancer. Every 6 minutes, we lose one person to breast cancer. This is true. I have the exact numbers with the WHO data. The reason is because nobody thinks that we should do annual screening like we do the glucose test, whatever, whatever. Nobody thinks we should do for cancer screening. Nobody thinks we should do for breast screening, right? That is the problem. We all feel, and everybody all women, including myself, when I didn't know, because I quit my job because I lost 2 of my family members to breast cancer. And I said, I'm going to research in this area 8 years ago. And that's what, thankfully, with God's grace, here we are. But the screening rate in India alone is 1.3%. 98.7% of women are detecting their cancer by hand, whereas the same number in US is 75% or so. So this is what I want to change. How can we enable screening tests so that every lady in India can take the test? The problems further that we want to solve is accessibility, affordability. How can we make it cheaper, cheaper, cheaper so that every diagnostic center can provide a screening test? How can we make the resource needed to run that machine cheaper and less skill needed so that more and more women and girls or whoever, like, less educated people or healthcare workers themselves can actually use these devices and detect cancer? There are other issues like user experience, where nobody wants to remove clothes in front of others to do the test. That is another big barrier. Can we make it privacy aware? So several of these questions, in the interest of time, I just go into the solution. What we have developed is a completely new test for breast cancer detection, where we just measure the temperature variations on the chest using an infrared imaging device like the cameras that you see here. We convert the temperature map to a cancer health report using AI machine learning algorithms. With this, we've proven that we can detect 4 millimeter lesions, stage 0 by definition. And we do that without touching the patient, without seeing the person when she's not wearing clothes. It's such a primary requirement, but no other test in the world today can do this. No radiation, no x-rays. We just measure the temperature on the skin, which is basically infrared rays coming out of our body. It's just a passive sensor. And there is a huge limitation today that existing methods work only on women above 45 years, and 27% of cancer deaths are under 45 today. I lost my cousin sister who was just 38. And that's the reason why I started this. But yes, so many 17-year-old I have seen with breast cancer. And this test does detect even in young women. It is 10% of the cost and 30% more accurate. And most importantly, it's very portable. You don't need to come to a hospital to do the test. You can take it out and do the screening outside. If horse doesn't come to the water, you need to take the water to the horse. I talked about no touch, no see. It's just like a photography session, and that's what happens. So let me quickly deep dive into what is the science behind it. It's definitely deep science. We have 39 patents in this. So everybody, most of you would know, but what is thermal imaging? It's just infrared imaging, which is one of the spectrums in the, electromagnetic spectrum, right? So what we do is measure the temperature variations on the chest, essentially using an infrared imaging device, as I mentioned. We measure 4 lakh temperature points. So we take a click with a very high resolution infrared imaging device and get this temperature value of every 4 millimeters of the tissue. When there is cancer, there is higher cell, there is higher blood flow, and so the area which is cancerous has higher temperature. But everything that is high temperature is not cancer. So how do we identify which high temperature? Secondly, if the cancer is very low, close to the chest wall, it doesn't even come to the skin. So can we map and create patterns of vascularity, feeder vessels, which are feeding to this blood flow? So essentially, we end up creating an algorithm or set of algorithms to detect very minute variations in temperature values and specialized algorithms to capture vascularity just using temperature values. So with this, we have been able to actually generate a report saying whether there's a malignancy or not, or whether there is an abnormality or not, red, yellow, green, what's the probability that it's malignant, and also giving a score so that you can even monitor over time, just like we monitor our blood glucose. Maybe we can change our lifestyle and literally prevent cancer. It is purely software as a medical device. We do not manufacture the infrared imaging device because there are so many companies who are manufacturing it. Thanks to COVID, there are more number of people who are manufacturing thermal imagers. So we measure the temperature variations, and the AI, a set of AI algorithms, convert that into a breast health report. There are multiple. First of all, I said I want to give this tool to the end users or even healthcare workers in the field. They make a lot of mistakes. Left go right, right go left, everything. So can AI make corrections when they actually make imaging errors? So we have a bunch of deep learning algorithms there. Can we extract the right kind of features? We have about 117 thermal features. These are called biomarkers, if you will, right? And also vascular patterns. And finally, we generate a report which can be read by a doctor. But you don't find doctors in a rural area. So for a rural area, we have a red, yellow, green automatically generated. By the time the lady comes out, the red, yellow, green is with a health worker. Whereas in a hospital setting, we actually give a detailed report. There are several machine learning algorithms, novel elements that have gone into it, right? To first of all, make the doctor see the image and abnormalities more clearly, as opposed to seeing a lot of red and yellow that you're seeing in the first image, etc. And I talked about vascular radiomics. I don't think you can see from far, but there are lots of, vascular extraction algorithms that we do. Behind it, these are all the magical CNN models and, VNet, UNet models that go in. We actually also take 5 views and convert a 3D reconstruction of it so that we can extract semantically meaningful features out of it. Multiple of them come together. I know I have a few minutes. So essentially, the report would look like a simple, like your blood report or an X-ray report or PET CT, automatically generated. There are about 25 different AI algorithms that work behind it. The scores, 3-4 scores that you see there, are the ones which tell, like if you want to monitor the health of a person post surgery, or like she's high risk because her mother had cancer, you could do so, right? These scores indicate, like, it's the probability score, 0 to 1 scores. As well as we came up with a final score called B score, which radiologists understand because that's the scoring they use. So these are some what we call as explainable AI. In addition, automatically the algorithm marks the likely area of malignancy so that follow-up diagnostic workup with an ultrasound or a mammo can be done. So it is a screening test. It is not a confirmatory diagnosis test. Once this one says it's high risk, then she needs to be brought to a hospital. The question is, does it work? So of course, that's why we took so much time to actually get into the field and do all this stuff. We generated the sensitivity and specificity graphs by making people take our test, followed by mammogram, ultrasound, and biopsy if needed. And at the end of the prospective blinded study, we compute how many cancers did we miss and how many did we call out of more. Sensitivity 100% means false negative is 0 in this particular, and many other studies we have done. False positives are about 8 to 10%, which is pretty much acceptable. And we have 56 plus publications in this, including Lancet Oncology. And even in young women, it's able to detect cancers which were missed by mammogram. And there are several, again, all of these are published literature, but I'm just sort of flashing it here. It does. It is amenable to go to rural areas. We have done thousands of screenings in many of the rural areas in Maharashtra, Karnataka, Punjab, Assam, Meghalaya, now everywhere, Uttarakhand, so many places. One of our studies in Punjab, funded by the Punjab government, 15,000 women screened, 3% of them found to be positive. Only those had to be brought. Of course, we're still struggling to get everybody to the next level. We already detected 27 cancer. So happened that to get the same result or even lesser number of cancers, 52,000 people were screened in a previous study because they were screening with hand. So clearly, this is detecting 3 times more cancer than hand-based examination. So this is another proof. This is a Nature paper that already has received 3,000 plus hits in just less than a year. There are several other publications, which I don't want to go into each of these details. But unless you want to take it to the market, you can't make it really useful or create an impact. And I realized that unless we get a US FDA clearance, we can't use it in India. It's not by rule, it's just by mentality. US approved, then I can use. But okay, so we went ahead, got the US FDA approval. We also got the CE mark and of course the Indian clearance. But because of the CE and US, we got many more countries when we got the awards and all. They reached out to us, and I'm happy to share that now this Indian innovation is used in about 25 plus countries. But mainly it is used in India. More than about 4 lakh women have actually benefited from this test. We have detected thousands of cancers. Unfortunately, just 2 days ago, biopsy, yesterday she finished her surgery. She was already 70-year-old. Still, she didn't know that she had to go for regular, but she detected with ours Just within a week, her surgery is done. She's happily back home today morning. Like that, we've actually detected many, many more people. But like I said, people don't need to come to a hospital to do the test. We do screenings in corporate offices. We do screenings also in rural areas and private screening at home. If any of your family members want to do, come to niramai.com, private screening at home. We'll send a girl home so that they'll do it in the privacy of your home. These are many of the countries who've adopted, including US. We have about eight to nine installations, but many other countries also have adopted. Many of the logos you can see, HCG, Polo, all of them have started. And also we do corporate camps. We go to a office, do the camp in the corporate office, and Google, Microsoft, everyone has screened. Here's the mobile medical unit. We go to the rural areas, to do the screening in private, where no one sees or touches the person. It's like a changing room. She goes behind, closes the curtain doors, etc. Only she's alone in front of the device. I'm very excited about this new project we are working on. How can we actually make this like a glucometer at home, selfie? And this is being trialed in Denmark and Germany at this point in time. It's very important to have explainable AI. And next time I have time, I'll explain this thing. But with all the, glamour that's happening around foundational model and so on, but there is real value to this as well. So we started working on foundational model. Can we use all the data, 1.5 million data that we have managed to collect, create a foundational thermal model and make infrared imaging a first-class medical imaging into it, not just for breast cancer, for several other cancers that are coming. I can't do it alone. I wanted to go into the depth here because I wanted to call out this wonderful, brilliant engineering community to come in and collaborate to see whether India can develop this excellent, non-invasive, medical imaging based and AI based technology for the world. Thank you so much for listening.
Thank you very much, ma'am. You have done an excellent work in the area of socially relevant problem for the country and for the world. So congratulations for that. I just want to make one comment regarding AI. You know, AI is not a matter of choice. It's a matter of existence as a nation. Because it's not just medical, it's not just science and technology, every part of science and technology, also in defense technology, in every aspect of defense technology. Bill Gates made a statement some time back that whatever our thinking I can do today is an understatement.
Absolutely, sir.
Thank you very much.
Just like computers were like, will anyone use computers? Now every farmer has a computer in his phone.
Yeah.
Absolutely. Thank you.
The last talk, which is remaining from the earlier talk, Jai Krishna Memory Lecture by Professor Anil Kumar Bhowmick. Do we have him on the line? It would be nice to have him here. Professor Bhowmick, are you hearing us? Oh, very nice of you. So, yeah, we can see your screen. We couldn't see you earlier, but we could see your screen, so that's fine. Let me, yeah, okay. So let me give a small brief about Professor Bhowmick. Professor Anil K. Bhowmick, former professor of eminence at the Indian Institute of Technology, Kanpur, Kharagpur, and founder director of IIT Patna, is currently a faculty at the University of Houston, USA. He is internationally known for his outstanding and seminal contributions to the development of polymer nanocomposites, sustainable materials, thermoplastics, elastomers, industrial polymer compounds, failure and degradation of polymers, polymer modification and addition phenomena in the materials, engineering disciplines, as revealed from his numerous awards such as 2025 Excellence publications have been extensively cited in the literature. He is recognized for his innovation and development of rubber products of national importance and rubber industries in India. We invite you, Professor Bhowmick, for your talk, about 20 to 25 minutes. Go ahead. Please go ahead, Professor Bhowmick. We are not able to hear you. Can you hear us? Okay. Yeah, we can hear you now. Your voice has gone. Can you hear us? Yeah, you can have. You can go ahead. Go ahead, Professor. Your voice is getting cut. We would request you to be near the microphone. Bhowmick, please summarize quickly. Please, please summarize in next 2-3 minutes. Fortunately, we got delayed, so we're requesting. Not able to hear you. Can you hear us? Okay, we have got practically all aspects of your talk. I hope you are able to hear us. No, internet access. Okay, what we can do is probably someone can call him and tell that we are concluding the session. Uh, and with this last lecture, I again congratulate from my side and on behalf of INAE to all the award winners, all 7 award winners, and also thank Prof. Dr. Deji Patil for giving me this opportunity to be part of this particular activity or in this session. It has been very interesting. I just wanted to convey to Professor Bhowmick that hope one day he will be able to develop time-dependent degradable polymers. That is what country needs. So thank you very much. We close this session now.
Thank you, sir. Ladies and gentlemen, we have just witnessed an extraordinary series of award lectures that reflect the depth, diversity, and promise of India's engineering community. On behalf of INA, I extend a heartfelt congratulations to all the awardees and gratitude to each of you for gracing this session with your presence. Thank you. Ladies and gentlemen, we hope you enjoyed the sessions and the insightful lectures delivered by our distinguished awardees. I request all the awardees to please come center stage for a photograph. May I request President INA, Mr. J.D. Patil, to please come on the stage. I request Professor Indranil Manna, former President INA, and the Vice Presidents of INA, please come on the dais. President INA, Mr. J.D. Patil. I request Professor Indranil Manna, former President INA, and the Vice Presidents of INA, please come on the dais.
Your voice is getting getting getting
Thank you
getting
to all the distinguished guests and the awardees. Special thanks to Dr. P.S. Goyal, sir. Thank you for chairing the
Getting
session all the distinguished guests and the awardees. Moving
Special
forward,
thanks to,
may I request Professor Indranil Manna, immediate
Dr.
former
P.S. Goyal,
President,
sir.
thank you for chairing the
Getting
session
all
all
the
the
distinguished
distinguished guests and the
stage.
awardees and share a brief description of INA membership on behalf of
Moving
INA.
forward,
Thanks to, may I request Professor Indranil Manna, immediate
Dr.
former
P.S. Goyal,
President,
sir.
thank you for chairing the
Getting
session all the distinguished guests and the awardees and share a brief description of INA membership on behalf of
Moving
INA.
forward,
Thanks to, may I request Professor Indranil Manna, immediate
Dr.
former
P.S. Goyal,
President,
sir.
thank you for chairing the
Getting
session all the distinguished guests and the awardees and share a brief description.
what we can do is probably someone can call him and tell that we are
On behalf of
Moving
INA.
forward,
Thanks to, may I request Professor Indranil Manna,
evening.
immediate
Dr.
former
P.S. Goyal,
President,
sir.
thank you for chairing
all of
the
you
all
are
the
exhausted
distinguished
after a very
guests and the
long
awardees and share a
and an
brief
extremely
description.
power-packed and information-packed session. We were very
what
happy
we
to
can do is
celebrate
probably someone can call
the
him and tell
achievements
that
of all
we
the
are
awardees.
On behalf of
Moving
INA.
And I,
forward,
Thanks to, may I
as you
request
must
Professor
be-
Indranil Manna,
evening,
immediate
looking
former
forward to
President,
joining the
thank you for
dinner.
chairing
I know all of you
all
are
the
exhausted
distinguished
after a very
guests
long,
and the
very
awardees
long,
and share a
and an
brief
extremely
description.
power-packed and information packed session for just another 20
So
minutes.
what we can do is probably someone can call him and tell that we are
On behalf of
aware
forwards
that
to may I
international
request Professor
academics
Indranil
Good
Manna,
evening,
immediate
Dr.
peer
Professor
will
Indranil
serve. Thank you.
Manjunath.
All the
Dr.
distinguished guests and the bodies and share a brief description.
Devoted power-packed and information sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
Devoted all aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
Devoted all aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
All aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
All aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
All aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
All aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
All aspects of intelligence and sessions for just another 20 minutes.
so what we can do is probably someone can call him and tell that we are
On behalf of forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
what we can do is probably someone can call him and tell that we are
Forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
what we can do is probably someone can call him and tell that we are
Forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
what we can do is probably someone can call him and tell that we are
Forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
what we can do is probably someone can call him and tell that we are
Forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a brief description.
what we can do is probably someone can call him and tell that we are
Forwards to may I request Professor Indranil Manna, immediate peer will serve. Thank you. All the distinguished guests and the bodies and share a
and set of benefits that go along with these recognition. The entire idea is that on top of 1,000 fellows, INAE would also like to have 10,000 members, individual members. The main reason is to be able to reach out and to be able to address the major challenges faced by the nation through collective effort. So today, with the permission from the President, Mr. Patil, we are going to invite those who have been selected as members, uh, coming from the corporate and also from institutions, but primarily confined only to the ones who are in the Bangalore region. In this short notice, we couldn't arrange or invite all those who are spread all over the country. But it's important that we announce before this learned audience, particularly the fellows of the academy, the main intention of INAE with regards to this new cadre called membership. For the individuals, I would like to clarify on behalf of the academy that members are a parallel cadre, but different from fellows. And we are certain that there are very many professionals who are serving in industry, academia, or R&D organizations who have made a huge difference, a significant impact, but don't necessarily qualify to be elected as a fellow because the yardsticks and the criteria for election to fellowships are different. And at the same time, they make enough contributions for earning this recognition. So just like FNAE, they also would be allowed to write M-INAE. But those privileges and benefits and so on are to be discussed some other time. Um, Consul Sharma, can you display the slides? And may I request Mr. Patil to kindly come on stage, and we would like to invite uh, the corporate members and institutional members, those who are present, to come and receive the certificates from the president. Are you able to display the slides? Yeah. No, I just wanted, while you are on stage, I wanted to just show them one or two slides. Yeah. So these are the privileges, the benefits of the corporate membership and the three categories, the criteria and the fees associated with that. We are very happy that Hindustan Aeronautics Limited, our gracious host, is one of the corporate members of INAE. May I invite the leadership from the MVJ College of Engineering, Professor N. Satyanarayana. Professor N. Satyanarayanan. Okay. Next, MRTDC Belgaum, Dr. S. Subramanian, Associate Center Head. He's Could we display the name of all the institutional members? Yeah, this is, so Dr. S. Subramaniam receiving the certificate on behalf of the MRTDC Belgaum. Thank you, Mr. Patil. I would like to apprise the audience of about the list of um, corporate members and the institutional members. So these are individual members, senior members. The criteria for getting selected as senior members is that one would have served the profession for at least 10 years, past the last degree of engineering. Yeah, they cover all the three categories: engineering institutions, academic institutions, R&D institutions, and of course, industries. So these 250 members, sorry, how many? 145. They have already been intimated. Another group of about 100. Okay. So these are the associate members. They would have acquired 5 years of experience from their last degree, and from various reputed institutions, not just um, academic institutions, but from institutions, from R&D institutions, industry. So these are 62. And on top of that, we have another about few, no, about another 100 who are at the last lap of getting selected. But this is quite small compared to the number that I mentioned. Our ambition is to reach up to 10,000 members. That will happen in course of time. We don't want to compromise with the quality. So these selections also go through a fairly stringent peer review process, which is overseen by one of the vice presidents. And through you, I would like to appeal to all those who are our fellows and beyond to take active interest in nominating individuals or institutions, even corporate or industries, for membership of Indian National Academy of Engineering. Thank you very much.
Thank you, sir. You are requested to kindly note the schedule for day 2 of INE Annual Convention 2025. We will begin the day with registration from 9 to 9:30 a.m. The inaugural session will commence sharp at 9:30 a.m. All delegates are requested to assemble tomorrow at the auditorium by 9 a.m. The detailed program for day 2 is displayed on the screen. We now request all the guests to kindly proceed at the dinner venue. Dinner has been arranged at the dining hall. We invite you to join us for the evening of delightful conversations and the meal. Please make your way to the dinner area. Thank you and have a wonderful evening.